okay, and then there will be a sealing gasket, okay, and then there will be one plate that makes up the cell, okay. Then there will be a 3mm flexible PVC gasket. This is where the actual cell gap is, okay. And then there will be the outside plate, okay. And that creates these active cell component, okay. So you've seen a cell, but there's no exits, okay. There's no entrance and no exits. The entrance and exits occur in these polypropylene spacers that I've made, okay. And this is a simplified version. The actual drilling is more complex. You can see on each plate I have 2 fittings for each one, and that's because there's an active cell plate like I just disassembled on this side, and the same thing on the other side. I'm only showing you one side right now for simplicity's sake, okay? And it's very simple. This is the secret to the circulation. I drill a hole edgewise. You can see what I've done. Drill a hole edgewise down to where the hole in the plate is located. Okay, so it matches up just like that, right? And then I drill a hole down through, not all the way through. It doesn't go to the other side, because if it does, then you have a breach in integrity, okay? And I do the same thing for the top. And what you end up with, as you can see with the gasket in place, is you have an entrance and a gas exit. And that's the secret to the self-circulating BB Smack Gen 5 design. Okay, there are many other ways to recirculate your cell, but what I wanted is to make something that was relatively simple. This cell is a little more complicated than my previous designs, and you guys know that one of my main goals is to keep these simple so everyone can build them. You know, that's why I don't do molding and fancy machine work. All this stuff is meant to be able to be built in your garage, okay? So this one's a little more complicated because when you get to the point where you've got 2 fittings here, you've got to make sure the holes have to be drilled at a very careful angles so as not to breach from one side to the other. That's craftsmanship. It can still be done by anybody. You just have to take your time. So this cell is going to require a little bit more diligence and craftsmanship versus like the Gen 1 where just about anybody can throw it together. You're going to have you know, a drill bits, and a really good eye. You're going to have to be careful, because if you breach, if the hole from this side and the hole from that side touches, you have just broken the isolation integrity, and now you have basically a wet cell design again. The advantage of this guy right here is 100% current isolation. There is zero, not a little bit, not a small bit, there is zero current leakage in this design. Zero, because the electrolyte from one cell does not ever come in any contact with the electrolyte from its neighbor. It's segregated all the way up to the bubblers, up to the top of the liquid level, and then by virtue of the gas outlet, they are tied together. But the electricity that is supplying electrolysis does not travel through the hydroxy gas. It only travels through the electrolyte liquid. So that's 100% isolation. Okay, and I chose polypropylene because it is a lot easier to drill than acrylic, and these complicated holes, cracking is something that can become a reality, number one. And number two, this stuff is way cheaper than acrylic. Now, don't get me wrong, I love acrylic, and the BB Smack Gen 4s are still going to be built with acrylic. So easier to drill, a lot cheaper, about half the cost, and also I don't need clarity. There's no liquid level. The liquid level is up here in the clear PVC, and the PVC is away from the cell body, so there's no worry about temperature. And plus, as you've seen from my efficiency video, this cell design runs way cooler. Okay, so what I'm going to do right now is I'm going to crank this thing up to 25 amps, and I'm going to give you a chance to see what happens when the cell cranks up. Now, I haven't flushed the electrolyte in this, so there are some floaties in there. This is the electrolyte, basically the original electrolyte. I haven't flushed this cell yet. This is the one that I used for the the genset test videos. Now you can see the blue tubing is where the gas outlet. The gas outlet comes down in the bottom and bubbles up through. Okay, so you can see initial on startup I'll get a little bit of foam. That foam's going to go away. That's just from startup, and you'll see it go away. But you can see, hopefully you can see in the video, you can see the foam and electrolyte being pushed up these 6 tubes. Okay, it goes up these 6 tubes and then down through to the bottom of the bubbler and bubbles up. Okay, so you can see each, like that's one cell gap. That's just one 8x8 plate cell gap. Okay, but there's 6 of them. So you add them together, right? You add them together through this gas output manifold. Okay, and it goes through the cup. And you know, right now, let's see, we're running about 25 amps. That amp meter's not really accurate, but it's close enough. So you're looking at about just over 2 liters a minute bubbling out through there. When the cell's broken in, it'll be 25 amps. It'd be 2.5 liters per minute. So this is pretty close. I mean, because I've done this so many times, I can look at that and I know that that's over 2 liters a minute. I'm not going to do a measurement test because I already did that in my efficiency video. So all you got to do is go back to that and look at it. So you know, and you know, it's good gas. You know, as usual. Of course, you can't really hear how loud that is in the video. But right now, I mean, my ears are ringing, so I don't normally do that without earplugs. So that's what's going on. Oh, and yeah, somebody said I was faking my test by not showing the output tube. Somebody was claiming I had the output tube hooked up to a hydrogen bottle. So I'm just showing you here. There's no hydrogen bottle. I'm going to trace this tube in the video right through, so you can see that this is the actual output of the cell. I don't know, people are always complaining. You can't make everybody happy, but I try to be as open, and I fully disclose everything as much as possible, so you know, there's nothing else connected to this guy, just in case anybody's wondering. Okay, so that's basically the construction technique, some of the advantages, and this is what happens. You can see now that I'm making foam in the cell. Basically, it's making foam. And once it makes foam and it starts pumping current through the cell, it pushes the electrolyte out and the levels in the bubblers rise. Okay, and when you shut the cell off, the level in the bubblers drain through the return tubes. Okay, so that's what you're seeing right now. I just cut the cell off for a second. Now I'm turning it back on, and you see the levels go back up, and that's an indication that your circulation is working properly. Okay, so. And that's basically what you're seeing. And notice very, very little foaming going on. Once you exceed the bubbler water, the gas that comes out, I mean, there's almost nothing foaming. So the chance of getting electrolyte mix into your engine intake is severely reduced. Not to mention the fact that this, just like my Gen 4 design, this is a double bubbler application. So you've got one set of bubbling, and then you'll have another set of bubbling. By the time the gas reaches your engine, it is completely dry and electrolyte free. So this is 100% safe for your aluminum intakes and aluminum pistons and all your sensors. Done properly, there is no issue with damaging or contaminating stock engine components.